All right. So I think we're going to get started. Uh, Hi, everyone. My name is Gaurav Malhotra, and I'm a program manager in the Cortana Analytics team at Microsoft. Before I dive deeper into what I'm going to be presenting today, I want to talk about a little about myself. So I was born and brought up in India, and I did my Bachelor's of Technology in Computer Science and Engineering from India. I moved to States in 2006, and since then, I've been working with a lot of companies and doing technical consulting for them. I've done in different verticals. I joined Microsoft in 2010, and I've been working with a lot of partners, customers, SIs to onboard them onto Azure. And I've worked on various services in Azure, and I've been with the Cortana Analytics team for last 2 years. Which brings me here, which means that I flew 10,000 miles yesterday to be here among you wonderful people, and I want to do the following. So my goal today is to dive deeper into Cortana Analytics. My session is primarily use case based, which means I'm going to be explaining the Cortana Analytics platform by diving deeper into services as I explain the use cases. You'll be able to understand the patterns when you see the use cases and we do the demos. I'm going to be using primarily two use cases today, connected cars and product recommendations. And my goal is to finish the session in next 1 hour, which means we'll open up for questions for last 15 minutes. Having said that, if you have any burning questions in between, please feel free to raise your hand and I shall be happy to answer those. With that, I want to get started, and I'm going to give a brief overview about Cortana Analytics. So how many of you over here are aware of Cortana Analytics Suite? So if I can see by show of hands, how many of you have heard about it? So quite a people in the audience, but I still see some hands not up there. So I always like to start with this particular slide because this slide allows you to see how customers are making sense of the data that they are capturing. So what has happened in last decade is that increasingly number of devices are now connected to internet. Ericsson actually predicts that by 2020, we will have 26 billion devices connected to the internet. So that is going to enable different use cases for us across different verticals. And this slide allows you to see those. And what we have been doing, the sales team, the data science team in Microsoft, are going after these verticals. And one of the verticals where we have seen explosive growth is sales and marketing. And the logic is quite simple. We have seen explosion of non-sensitive customer data in this segment. And this marries well with the scalability of the cloud. Another segment where we have seen explosive growth is customer and channel. And here, customers are trying to do personalized offers. And the online retailers are trying to provide personalized product recommendations. So what you can take away from this slide is that the opportunity is huge. The opportunity is huge not only for Microsoft, but also for our customers, also for our partners to drive analytics in that particular space. What does that mean? That actually means that data today is ephemeral. So there are, like I said, a lot of devices are connected to the internet, but intelligent action is not. And that's what we want to do with Cortana Analytics. We want to drive value from data into intelligent action so that customers can move from what happened, those are the static reports that we are pretty much used to why did it happen? Essentially interactive dashboards. Again, we see that today quite often in the market, to what will happen. So if you can predict what can happen in the future, and then not only can you predict, but also if you can provide recommendations, what should I do? And can those recommendations be automated, or in some cases, manual intervention will be required? So only when the enterprise will be able to do this, then they will be called as an intelligent enterprise. And again, the opportunity here is huge. IDC predicts that companies who will be able to unlock this value from their data have a business opportunity worth $16 trillion. So again, it's entirely up to your organization whether they can take this data and drive efficiencies in their business processes, whether they can change their existing processes to get more value out of it. So with this, what is Cortana Analytics Suite? And this is a question that we've been asked a lot. So Cortana Analytics is an end-to-end platform, and it is composed of a bunch of services and tools that allows you to build end-to-end analytics, that allows you to transform data into intelligent action. So what does that mean? So what you see on the left-hand side here are these business apps, custom apps, or your sensors and devices that are connected to the internet. And these devices or these business apps are continuously emitting data. So what we have in the information management layer of Cortana Analytics is our services, different services like Azure Data Factory. So Data Factory is a globally distributed, scalable ETL service on the cloud, and it allows you to ingest data. And it allows you to ingest data not only from cloud sources, but also from on-premise sources. And we support a bunch of sources there like Teradata, Sybase, DB2, Oracle, on-prem SQL Server. And again, for cloud, we support all the Azure sources today like Azure SQL, Azure Database, Azure Table, you name it. And we are on a very aggressive path to add more connectors as we speak. So there are other services in this layer as well, like Azure Data Catalog, that allows you to build a catalog of your data sources so that you can only define them once, and different business units within your organizations can use that so that they don't have to create those data sources again and again. Or you could be using Azure Event Hub, which is our service that allows you to ingest data in real time. It's built to scale. You can ingest millions of events per second using this particular service. So Event Hub allows you to ingest data in real time. With Data Factory, you can ingest static data. So once you have ingested the data, what you can do is you can build your big data store. And this, again, can be done using multiple services that Microsoft has. It could be done using Azure Data Lake, which is our newly announced capability 2 weeks back at SQL Pass. It is in limited public preview. And this is a repository that allows you to store data of any type, any size. And this repository scales as the data scales. So you don't have to worry about size over here. It is built for exabytes, petabytes of data. Also, we have in this particular layer is the only petabyte scale data warehouse in the cloud, which is Azure SQL Data Warehouse. And with this, you could scale up and down by switch of a button. And this is very powerful. It's very powerful for online retailers now that the shopping season is coming. They can scale their data warehouse by the units that they want. And once the shopping season is over, they can scale it down as they want. So now you have built your big data store. Now it's time to do analytics. And again here, analytics is not only about machine learning. It is also about running big data queries like Hive, Pig, scalable distributed queries. And this can be done using our capability, Azure HD Insight. This is Hadoop that we have brought onto the Microsoft platform. Or you could be using Azure Stream Analytics, which is our capability that as you ingest real-time data through Event Hub, you can gain real-time insights into the data by writing queries in SQL type format and dumping the data to Power BI, to SQL, whatever you like. So, and machine learning, of course, you can build statistical models, you can do predictions, and we have modules in the workspace that you can import, build your own modules, and use them for your machine learning. So once you have done this analytics, now you're onto the stage where you want to visualize your data. So we have Power BI, and there you could build interactive dashboards. It's entirely up to you what type of graph, what type of visualization you want to use. Or you could have integrated Power BI with Cortana, which is using our natural language processing capabilities. You can ask questions in real time, and Cortana will be able to answer those questions. Or you could be using our perceptual intelligence APIs, like face detection APIs, like text analytics APIs, like product recommendation APIs that we have in the store. So if you want to build some websites and want to use all of those APIs out of the box, they are available in the machine learning gallery today. And you can also enable end-to-end business scenarios, as you're going to see that those in the demo today. You could do product recommendation, you could do customer churn, that these are the customers that are about to leave my platform. So you could build machine learning models for that and predict that. So once you have done this, now you have people or automated systems consuming that data. So you have transformed your data into intelligent action. And you can see that both sides of this particular platform are open, which means they are extendable. So you can write any code to extend this. You could have integrated with a CRM application, Microsoft Dynamics CRM application, or any other CRM to import your customer data, if you will. And all of these services that I talked about have APIs, which means you could go entirely programmatic and do all the stuff programmatically. So now that we have seen Cortana Analytics and what is Cortana Analytics and what are the services in Cortana Analytics, how many of you have used these services, one or more, to build end-to-end solutions? So if I can again see by raise of hands. So I see 2 or 3 hands. I certainly hope that after my session today, that dynamic changes so that you can go back home and take the patterns that I'm going to show you and build those solutions. So with that, I want to actually go into the connected car demo. And as I go into the demos, I will stop, take a moment, and explain the services that I talked about in the Cortana Analytics suite. So before I go into the connected car demo, I wanted to talk a little bit about the connected car market. And connected car market overall is huge, right? And what we are going to be showing today is a subset of that you can achieve. And you'll see that there are a bunch of cases out there that you can also do and build upon this demo that I'm going to show you. So overall, what Gartner and Forrester have said that over a period of last 5 years, there have been 45% compound annual growth rate for the connected car market, which means that it has grown 10x faster than the overall car market. 75% of the global car shipments by 2020 will have the ability to connect to the internet. And how can they do that? So essentially, there are 2 mechanisms. They have this native ability. Cars will have native ability to connect to the internet. Or they could be relying on a secondary device, which is a OBD2 device, which I actually brought with me. I just bought it for like $15 from Amazon. So you can actually plug this particular device into your dashboard. And this device has the ability to connect to the internet. And you will see when I talk about use cases, there are a bunch of insurance companies, even in Australia, who are using this today to enable usage-based insurance. So what we have been seeing is that the embedded connections are winning. So essentially, cars will have this native capability as we move ahead to connect to the internet. That doesn't mean the secondary devices are going away anywhere. They are still very much in use today in the market. So I said that 75% of the cars will have the ability globally by 2020 to connect to the internet. So what sort of use cases does it enable? So before I go into the use case, I actually want to show you a live demo of one such use cases. So let me ask this question to you. How many of you over here like aggressive driving? So if I can see by show of hands. Okay, so would you like to come on stage? I'm going to do a very short demo with you and show a particular. It's very simple. You don't have to do anything. Come on, come on. Come, come. What's your name? Benjamin. Thank you for coming up. So what I'm going to do is that I have this particular app that allows us to see. I'm going to shift this. And And I'm going to open this particular app. I'm trying to, so something happened. I'm going to plug it again. Yes. And yep, we can see it over here. And I'm just trying to come out of this. Sorry, guys. Essentially, yeah, so essentially, yeah, now we are back. Yep. Contoso. So if you can hold this, and if you tilt it down, you will see that it increases the speed. And Cortana is actually speaking at this particular time. So Cortana is saying essentially that you're trying to drive fast, and as he tilts down the speed, tilts down the phone, it symbolizes that he's increasing the speed. So now let's go into the second one where he's going to continue to drive aggressively because he's an aggressive driver, aggressive person. And so essentially the engine light has come up now.
Engine light has come on. Based on my analysis, it looks like it's an oxygen sensor issue. You need to get this checked out by your dealer. Would you like me to schedule an appointment?
So if you can just say yes, say yes.
Yes, please. Should I have said that aggressively?
No.
Okay.
And it's saying if PM tomorrow is fine.
That's fine. Yeah.
Yes. Yes.
I've scheduled it.
All right, so it has scheduled it. So now you can see, thank you so much for coming up. Big round of applause for him. So you can see that one of the use cases that it enables is a usage-based insurance where companies like insurance companies can track the usage of how you're driving the cars, and based on that particular usage, they can actually work with you, and your essentially your insurance will go up or down. And I'm going to show you there's a company in actually Australia. It's called Insurance Box, and they are actually running this particular program. And their program allows them to track. They essentially use this OBD2 device that goes into your dashboard, and based on the user statistics, they actually work with you to see whether your insurance will go up or down. Similarly, in US, we have Progressive that is using a program called Snapshot to do the same. So what I'm trying to show over here is that this is one of the scenarios. There's other scenarios, like we saw that Cortana was able to see that you're driving fast, and it was able to see that the light has come up, and it is able to raise proactive alerts and work with you to schedule the maintenance. So usage-based analysis, telemetry analysis. And it could also be used by car companies, rental companies, to do fleet management if they wanted to. And so you can see on this particular slide different use cases, and what we are going to be focusing today is particularly vehicle telemetry analytics, where the car is pumping a lot of data, and we are actually looking at that particular data to see your usage patterns, to see whether your car actually needs maintenance, whether your car is having any issue, or whether it's a recall model or not. So what I'm going to do is switch on to the particular visualization. So this, you can think of this particular demo as a Contoso car company that's based in Redmond, Washington. And they've been in operation for last 10 years. So what they have done is that they have deployed this connected car solution, And with this connected car, it allows them to gain real-time and predictive insights into vehicle telemetry and usage-based telemetry that how a customer is driving the vehicle. And they'll be able to use that to do certain things. So in this particular demo, what I have on the left-hand side, from the vehicle by city to the left-hand side is the real-time portion, and on the right-hand side, it is based on static data from which we are determining certain patterns. And you can see on the left-hand side, certain bars are going up, the balls are moving, because what I'm doing is that I'm running a car telematics simulator. So it's this particular simulator which is generating a data, emitting a data just like a normal car would. And this data actually goes to Event Hub. So there's Event Hub that's a capability that Microsoft has to ingest multiple events that I talked about. So I go in my service bus that I've created, and it has 2 event hubs. And one event hub is for ingesting the data, and the second one is for egressing the data once it opens up. So the data comes through the car telematics simulator. It goes into Event Hub, and then I have a stream analytics query running, which is our ability to do analytics in real time. So I have a query running over here, and it has 3 portions in it. The first portion is I'm taking the data that is being emitted by my car telematics simulator for actual use cases. It will be actual cars, joining it with some reference data in the blob, in Azure Blob. And this data that I currently have, the reference data in Azure Blob, you can have it at any location. So you can see in my inputs are Event Hub source and the blob source, which has some reference data. So the first query just joins the reference data in blob with the real-time data that I have, and dumping the data to a SQL database. And my Power BI dashboard is hooked up to the SQL database, and it is running on a refresh. So you can see over in the output, I actually have 3 outputs. I'm dumping it into blob for batch analytics. I'm dumping it to SQL, and also sending it to an output event hub, which will know why we are doing it in a minute. The second query that I have over here allows me to do anomaly detection in real time. So I take the real-time data that is coming in, and then I just send the data as is to the output event hub, which was one of the outputs that I showed you over here. And then I have an app running. This is a real-time event app that is running, that is calling a machine learning model. So it is calling a model that has been built in machine learning to do anomaly detection in real time. So the left-hand portion of this particular model is a maintenance anomaly, and this corresponds to a particular tile in Power BI, which I'm going to talk about in a minute. So I send this real-time data to this machine learning model. It detects anomaly based on tire pressure, based on engine temperature, based on fuel oil, and it sends the output back to me, which I can see on this particular Power BI dashboard, which is vehicle requiring maintenance. And this tile is being generated by doing anomaly detection in real time. So this tile has a particular information inside it. As I dive deeper, you can see the number of vehicles that require maintenance. You can see that the most number of vehicles that require maintenance are in Redmond. You can see that now the VIN numbers. You can also see what types of vehicles require maintenance. So you can see that sedans are the most number of vehicles that will require maintenance. So this is real-time insights, and this enables a lot of useful scenarios for Contoso, because now what they can do is that they can run a personalized marketing campaign, because they know that these cars will require maintenance or they need engine oil change, so they can run a 10% coupon to a particular guy in Redmond, right, and get their business. So this is insights in real time, all powered through Cortana Analytics. You can also see on here vehicles in operation. Again, it allows you to see the distribution. It allows you to see what types of vehicles by the area. We can see Bellevue, which is a city in Washington, has the most number of vehicles, followed by Seattle. You can also look them up in the map. You can also see that by the distribution of the vehicles in Bellevue, and you can see that the most number of vehicles in Bellevue being driven are sedans, right? So rich visualizations that you can get from Power BI over here. If I go back, I can see other visualizations in real time as well. I can see that what is the average speed of all the vehicles driven, what is the average fuel, what is the average tire pressure, average engine oil, and all of these are again is again a query over here. That's the third query that we have over here, which allows me to do aggregation in real time. So I'm doing a 3-second aggregation, and it's tumbling window, which means those are non-overlapping 3-second windows. And I'm doing an average of engine oil, average of tire pressure over here. And you can see that I'm doing that average. So I take this, dump the output to SQL, and I have these tables in SQL, as you can see over here. And these tables are directly hooked up to my Power BI dashboard that I have. And we are seeing the visualization over here. If you wanted to, you could have sent the output directly from Stream Analytics to Power BI as well. We do support that. But I just wanted to show you another pattern that we have seen very common in the industry, where people move the data to SQL and then the Power BI dashboard is hooked up to it. So now we have seen the real-time portion of this particular vehicle telemetry analytics demo for connected cars. Now let's look at the right-hand side portion, and this is basically batch analytics based on static data. So here, what you can see is that we have different tiles which are aggressively driven vehicles, fuel-efficient vehicles, and all of this is being powered by pipelines that have been built on Azure Data Factory. And let me show you what Data Factory is. Essentially, Data Factory, like I said, apart from ingesting data, it supports a bunch of other scenarios. So Data Factory allows you to build a network of pipelines, which means you can run your Hive big queries across big data processing environments like HD Insight. You could run uSQL queries, which is the newly announced capability for Azure Data Lake Analytics, against Azure Data Lake Analytics service. Or you could write a custom .NET code and run it against an Azure batch environment, which allows you to create VMs. Or you could run it against an HDI environment, entirely up to you. So you can create these network of pipelines, you can ingest data, you can monitor and manage that from a single pane of glass. And I'll show you in this, we have a diagram view that allows you to monitor operational lineage of your data flows. And you can see how data is flowing, you can see where errors have occurred, you can debug those errors and correct them. And that's basically our biggest value prop for monitoring and management. So in this, before I go and show you how this connected car pipelines that are built on Azure Data Factory are working, I need to explain you 4 concepts that are in Data Factory. The first one is link service. So link services are nothing but connection string to your store. And I'm going to use this author and deploy mode that we have over here. This is a lightweight editor that we have in UX. We do support, we have a C# SDK. You can go through PowerShell. It's entirely up to you what you want to choose. So this editor allows you to see what a link service is. It's just a connection string to your store. It can be a connection string to your SQL database. It can be a connection string to your blob storage. So once you have created your link services, then you define your data sets. So data set is nothing but a named view on top of the data. So Data Factory is neither a compute nor a store. We are just command and control. So these data sets allow us to reference the data that you have in your big data store. So this data set has few important things. You can define your schema. Then you can tell us where the data is. So in this case, the file name is this. It's in a storage account, Azure Blob, of type Azure Blob. Here is the location where my file is residing. And then I have chosen to partition my data. And we support rich partitioning scheme by day, month, hour, whatever you want. And then there's an availability section over here, which allows me to see that this data set is being generated once in a month. And you control this frequency. You can be running this every 15 minutes, every week, every month, every year, entirely up to you. So now you have created your link services, you have created your data sets. It's time to create your pipelines. And pipeline is nothing but a logical grouping of activities. So in this particular case, you can see that I have an activity of type Hive. My Hive script is this, and it is located in a storage account that I have defined in my link service section. These are the parameters that I want to pass to my Hive script. Every activity has an input and an output, and these inputs and outputs are the data sets that you created. So here you can see that the input is partitioned events table, which means that only when that particular data set has been generated, then this Hive query will run and produce the output data set. And then you have ability to define rich policies, which means you can have a timeout, you can define concurrency, you can define basically retries, whatever you want to put in these. And then there's a start and end, which is essentially how long you want this pipeline to be active. So you can see that this entire experience is JSON-based. So you can put different values, deploy these particular pipelines. And once you have created your link services, your data sets, and pipelines, you can visualize this from a single pane of glass that I was talking about. And that's our diagram view. And this diagram view allows you to see the operational lineage. So you can see over here that we have the car events that are coming in. We are partitioning those events. So we are running a Hive activity to generate a partition because I want the downstream operations to run on that particular partition only and not on the entire data all the time. So we partition the data, and then there are 3 pipelines that are running in parallel. And we can see over here, let's go back and look at what tile we were looking at in the Power BI dashboard. And we have this aggressively driven vehicles. So let's go in this particular tile. And again, in this particular tile, we can see that there are so far 2012 vehicles that are being aggressively driven. We can see that by what time they are most aggressively driven. So it's June, which is in line with the summer months in the United States. And then we can see the location on the map. We can see the vehicles that are being aggressively driven, which are sports cars, followed by large SUVs. So this visualization is powered by this particular pipeline in Azure Data Factory, which is aggressively driven pattern pipeline. So I can double click this, and I can see that there's a Hive activity that is running. You can see that this is a HD Insight Hive activity. I can click this, and I can see the activity script. So I can see that there is a partitioned events, and then at the end, I have the business logic defined to say what is an aggressive driving. So anytime my gear position is in 4th, 5th, 6th, 7th, or 8th position, or my brake pedal is not pressed, which is signified by 1, and speed is greater than equal to 50, I categorize that as aggressive driving. You can define this business rules as per you will and run this particular Hive activity. Once this Hive activity runs, it actually generates the data in Azure Blob, and then we are using the copy activity that I talked about, that Data Factory has capability to ingress and egress data. So it is copying the data to an Azure SQL database, and the Power BI dashboard that I showed, this particular tile is hooked up to that Azure SQL database and running on a refresh. Similarly, we have other tiles over here, and if I can look at the recalled vehicles, so we can see that so far there are 505 vehicles that have been recalled since 2014. Most of them are family saloons followed by hybrid vehicles. I can see in the location where they are mostly recalled from. And this is again powered by the data factory that we have. There's a pipeline here. And here, there's an interesting thing happening. So if I go inside this particular pipeline, I right-click click it, and say Open Pipeline. I'm doing some preparation, and then the meat of it, I'm running a Azure machine learning activity. I'm calling a machine learning activity, which is, again, the machine learning model, which we saw earlier, has two parts. So the left part was being used for determining vehicles that required maintenance in real time, that part I showed you. And the right-hand part over here is being used to determine whether the vehicle needs to be recalled or not. So from Data Factory, we are calling that particular path over here. And then we are dumping the data to Azure Blob Storage. So if I go back, so I'm here, and then so this machine learning algorithm, when it runs, it generates the probability of recall. And then I'm running a Hive activity again over here to say that anything that is greater than a particular percentage, I want to recall it. Again, as a business owner, you have the ability to define what recall probability you want to specify. In this case, I have chosen it 50%. So once this data gets dumped into the blob, and I use the copy activity in Azure Data Factory to move the data to Azure SQL database, and my Power BI dashboard here, this particular tile is hooked up to that SQL database and running on a refresh. So you can see that this is so powerful for a car dealership or a car services company, because not only can they gain real-time insights, but they can also gain batch insights into their data, and they can, based on that, run product marketing campaigns. They can do proactive alerting to say that you are driving fast, or they can work with you to schedule maintenance. So a lot of cases that it enables for a car services company using Cortana Analytics. So before I jump on to the next demo that I wanted to show you, I wanted to tell you that all of this will be enabled. So I showed a bunch of pieces to you. So now the question is, how will this be enabled, will be available to me? So we are working to enable a piece in the machine learning gallery. So this is our machine learning gallery that you can today go to. There's a piece that is coming up later this year, which is called Solution Accelerators. And in this Solution Accelerators, we are trying to enable some pre-built solutions that you can use to see patterns. You can take them, change them as you will, build your own on top of that, extend them, entirely up to you. So you can see over here that the first one over here is vehicle telemetry analytics, which I showed you. So the next one that I want to talk about is product recommendation. And before I go in there, this solution that I showed you was using all of these services in the Cortana Analytics, the vehicle telemetry analytics for connected car. It was using Power BI. It was using all the services in the analytics space. It was using Azure SQL for storing the data. And we were ingesting data through Event Hub and Data Factory. This is a demo architecture. And you will see that this demo architecture is pretty much same across the second use case that I showed you as well. There's a data in motion, the real-time portion on the top, and then there's a data at rest, which is at the bottom. So my car telematics simulator is generating the data. It's going to Event Hub, and then I'm doing real-time analytics using Stream Analytics, running SQL-type queries over there. I'm calling machine learning model to do real-time anomaly detection, and then I'm dumping the data to Power BI, and we had Cortana as one of the examples that I showed in the demo app, talking to Power BI dashboard as well. And then there's this data at rest portion that's below, which is Once I get real-time data through Stream Analytics, I'm spooling it to a big data store. It could be Azure Blob, Azure Data Lake, and then I'm running Hive BigQueries over that and also calling a machine learning model. This entire piece for data at rest can be operationalized, scheduled, monitored through Azure Data Factory, as I showed you in the demo, and you can consume it through Power BI in the end. So we already seen the Power BI dashboard, which brings me to the next demo, which is product recommendations. So I've showed you one vertical. I wanted to touch base on another vertical, which is the online retailers, which is quite popular today, and talk about product recommendations. So before I go into the demo, again, I want to talk about what is product recommendations. So generally, there are two types of product recommendations. One is product-to-product recommendations, which means that I do not need to understand your profile to provide you a recommendation. I do not need to understand that you have bought a particular product in last 6 months to give you a recommendation. For example, if you buy a phone, then if it doesn't come with a headphone, then it's quite obvious you're going to buy it. And then the second type of recommendation is user-to-product recommendation, where I'm tracking your behavior. I'm seeing what you're doing, what products you are adding to the cart, what purchases you have made in last 6 months, and providing recommendations based on that. So essentially, again, I have different facts from Forrester and Gartner. There are 100% of retail websites today, they are devoting space to product recommendation. Biggest retailer websites, they have 70% of their space devoted to product recommendation. They have 25% of their workforce actually working on product recommendation. So what does this mean? Why are they doing this? The logic is quite simple. They are trying to increase the sales revenue. They are trying to increase the conversion rate. So if I'm going to provide a recommendation that is suited to you, that is based on your requirement, there's a highly likelihood that you're going to buy that product. So that's going to increase the conversion rate for me, and ultimately it's going to increase the average order value, which means more dollars for my company. So what we are saying is that you can build this entire product recommendation pipeline using Azure Data Factory. We actually have retailers who have built this entire workflow on top of Data Factory. So whenever you go to their site, the widget pops up. It's being done through Data Factory. So they can do both personalized product recommendations, and they can do product-to-product recommendations. And again, here you could use Azure Machine Learning APIs to do product recommendations. But here's the kicker. You can also use open source. You can use open source Mahout. For people who don't know, Mahout is a library that is shipped by Apache. And this has machine learning algorithms that you can use. And one of the algorithms that Mahout has is for product recommendation. So they support 2 jobs there: item similarity, which is product-to-product recommendation, and they support a recommender job, which is user-to-product recommendation. So you can run, so that ships as a jar, Mahout comes as a jar, and you can run that map as a MapReduce activity in Azure Data Factory. And we're going to see that how. So like I said, today we'll be talking about Mahout. And the scenario is pretty simple. You have customer information, which is the customer demographics, age, location, region. You have your customer behaviors, what products they have purchased, what products feedback they have provided, what products they've added to the cart, and retailer events, which is essentially product introductions, brand introductions. So you marry all of them together and feed it to a recommendation system. You get personalized product recommendations and product-to-product recommendations. And you can use those through multiple touch points like retailer websites. You can use it through RSS feeds, or you can do personalized emails if you wanted to. So let's go and see how this is built using Azure Data Factory. So before I go there, I have this demo website that I created. I want to show you what that means, what personalized product recommendation means, and what product to product recommendation means. So if I just go here and say login, uh, it's going to ask my username. Probably it has timed out, so it's taking it some time. Yeah. It's the most insecure way of logging, so don't do that ever. Uh, so if I log in, it shows me top recommendations for Gaurav Malhotra. And what it has done, the pipelines have been built in Data Factory. They have run, and based on that, based on my usage, based on products that I've added to the cart, it has run the Mahout recommender job and found out that I'm also interested in listening to these particular artists. So what I have by default is a music store, and I have titles over there. And what it is saying is that for Gaurav, these titles are also interesting. So he should be listening to those. And I can go ahead and click on one of this particular title and see product to product recommendation, which is people who have played One Giant Leap also listen to this. For this, we didn't track any usage behavior. It's just based on common knowledge that people who have listened to this particular type of music have also listened to these titles. So how did we build this? So what we have over here is a product recommendation factory. And again, it has the same pieces that I showed you. I'm going to go straight into the diagram view so that I can explain what is going on end to end. And you see a red over here. I've intentionally failed one thing because I wanted to show you how a failure would look like and how you'll be able to debug it and correct it. So let's start from the very beginning. So I have a prepare data pipeline because I don't want to use any retailer's data. I have created a .NET activity. So this is .NET code that you can write and use this as an activity in Azure Data Factory. All you need to do is extend an interface, and we provide certain methods that you need to override, and you can write any code, which I have done here. So I'm generating some sample data as the first part in this particular pipeline. Once I have the sample data, I'm running a Hive query to partition my data. So let me show you how this looks like. So my raw usage events are here, which is the artist customer data. And I'm partitioning the data, and you can see that I'm partitioning by month. So now you'll be able to understand, and I showed this in Connected Car as well, so you can work only on that particular partition. The downstream operations can only work on that particular partition, and that's why we are doing this partitioning. So once I do the partitioning, then I'm doing preparation because I want to feed the data to Mahout, and Mahout actually accepts the data only in a particular format. So I'm doing a prepare step. So what does that mean? I have my raw data like this, which is user ID, product ID, whether the title has been played, and timestamp. I partition the data to generate a partition corresponding to a particular month. And then I feed it to the prepare step, which is a Hive activity, which just takes away the last column. So it only selects the first 3 columns here. So that's why you don't see a timestamp in this input. So these are all files that are being generated by the pipelines that I'm running in that particular workflow. So if I go back, I'm here. I've generated that particular file, which is this input table. And you can see that this has failed. So there's a failure that is coming in here. You can go look at this. You can even look at the log files that have been generated corresponding to this, download those log files, and if you figure out the error, you can rerun right from here. So if I come back, I've prepared the data, and now what I have are 2 workflows. So once I have the partition data, I could be doing a user to product recommendation, which is the bottom part of this workflow, or I could be doing product to product recommendation, which is the top part of this particular workflow. And in order to do that, I'm running the Mahout jar. And the way to run that is following. You open up any pipeline here, which is, so I'm opening up the item similarity one, which is product to product recommendation. So if I go into this MapReduce activity, and I look at the activity script, I need to go to we actually recently moved this, so I need to go into the lightweight editor that I showed you earlier in order to show this to you. So I'm going to open up a MapReduce pipeline. So you can see over here that I'm actually running a jar. Yeah, this one. So I'm running a particular jar. So I'm running the item similarity job in the Mahout jar. And I'm passing these arguments to that particular jar. And again, once my input data is ready, then this job will run and produce the product similarity table, which looks like the following. So so once the Mahout jar runs, it says that this product is similar to this product. And again, this is the probability that it has generated. So I, as a retailer, now have a choice whether I want to select 70%, 80%, entirely up to me. So what I have done in my case is chosen the threshold to 70%. And we can see that, again, I'm running a Hive activity here. So once I get the output, I'm running a Hive activity where I have chosen the probability greater than 70% as products that are similar. So you can see that I've chosen 70% that is similar. And once I get those products, I move the data again to a SQL database. And my website, demo website that I showed you, is hooked up to this SQL database. So it actually, in SQL database, it generates a table like this: product ID and similar product ID. So similar product ID and product ID. So that's how we are getting the product-to-product recommendation. Similarly, we have the second workflow over here that is running the recommender job that ships with Mahout and doing the exact same things. So it generates the output, and then I run a Hive job to flatten the output, and then I move the data to a SQL database to generate, for this customer, this is the recommended product. And again, my demo website is hooked up to this, and that's how it is getting it. So if I go back now to the presentation and talk about, again, the pattern here. So again, we had 6 stages over here. We had data sources, which were the weblog files that my website is generating. I'm ingesting them to blob storage. Again, doing that through the copy activity in Azure Data Factory. And then I'm preparing the data. So you saw that I was removing the timestamp column. You could be doing some other actions as part of data preparation step, or running some custom code. And then you are analyzing the data. So you could be doing machine learning algorithm. In our case, it was Mahout. You could be using the product recommendation APIs that we have in the space, in the machine learning gallery. And what we have generally observed with customers is that all these operations are being done in the cloud, and then you publish the data to a data mart or a SQL database and consume that data through your apps or through a retail website. So this entire workflow, we saw that we were able to orchestrate, operationalize, schedule, and monitor using Azure Data Factory. And our goal is to be the data integration platform with Azure Data Factory. And just like System Center, you're able to monitor your hybrid assets with Data Factory. We want to provide that capability to you guys. So with this, now that we have seen 2 different verticals, and we have seen how you can use the services in Cortana Analytics Suite to build end-to-end solutions, I want to talk about another space, which is websites. And for this, I want to use howold.net. This was a website that was actually launched during the Build conference by our VP, Joseph. And this just started as an experiment. So how many of you have heard about howold.net or tried it? Okay, great. So quite a few number of people. So what I'm going to be showing you here today is not what howold.net can do. Of course, I'll talk a little bit about it, but I'm going to talk about that how it became a big data problem for us. So for folks who do not know, you can actually go and open up in your mobile browser right now how-old.net and try and upload your photograph. So what this site does is that you can upload any photograph that you have, and for now, I'm going to use one of the photograph that's there in the gallery. And it calls our face detection APIs to predict your age. So my wife tried this a lot. She tried every picture till it said that she looks younger. So yeah, it's quite hit among the girls. So you can see that we're using the face detection APIs, and the way it works is that it looks at the statistics of your face, and based on those, it tries to predict your age. So I said that this became a big data problem for us. So what does that mean? I'm going to show you a Power BI dashboard, if I can switch to that. And you can, again, here you have a real-time portion and a batch portion. You can see some graphs jumping up and down, and you can see some numbers. So you can see on the top row, the second tile, which says number of photos uploaded, which means so far, more than 500 million people on the planet have tried to upload their photograph and tried to predict their age. So we were actually contacted by FBI for this, and they were wondering what we are doing because you cannot actually, this is personal information. So we actually do not store your image. We just analyze your face, predict your age, and throw away the image from memory. So we were good over there. So this became a big data problem because as the data was coming in, we wanted to gain real-time insights. So again, we have a query in Azure Stream Analytics. So I'm going to go to that particular subscription that has this query. And you'll be able to see that how we gained these real-time insights from the data. So once you upload the photograph, it goes through Event Hub, and then we have this real-time query that is running in Azure Stream Analytics once it opens up. That allows us to get these real-time numbers that are jumping up and down. And we get those numbers and push the data directly to Power BI. So let me go to Stream Analytics. And I can see over here real time. And I can see that I'm running a query to get some of the statistics. It's just like SQL type query. And my input is Event Hub, the stream that I'm connected to. As you upload a photograph, we are sending the data to Azure Event Hub. We are running the query, and we are pumping the data directly to the Power BI dashboard. And that's why you see these charts jumping up and down. So this is the real-time portion, but you also see on the bottom of this some batch analytics. And you can see over there that this was launched in May, and around about later half of the May, we had 15.7 million photographs uploaded in single day. So that was just after the conference when Joseph announced this. And this pattern is being done by running Hive queries, and we have built a pipeline in Azure Data Factory that allows us to give these insights. So users by day, photos by day, users by platform. So it looks like this. So again, I'm going to open up the diagram view here. And you can see that I have the raw data. So as you upload the photograph, the data goes to Event Hub, the Stream Analytics query runs, and it also spools the data into Azure Blob, and that's the starting portion of these pipelines. And then we again partition the data, so similar pattern that I have showed in other two demos as well. And then we have different pipelines here. So these are essentially insights that we want to gain into the data. These are all Hive queries that are running, and you can see users by day, users by platform. And once I run those Hive queries, I get the output. Then I'm using the copy activity to again move it to a SQL database, and my Power BI dashboard is hooked up to these SQL databases and running on a refresh. So you can see that it's so powerful, and just to let you know that all of these pipelines we were able to build in a couple of days. And the Stream Analytics jobs to get real-time insights on Power BI, you can build that in a matter of hours because it's just connecting to the input and then writing queries in a familiar SQL-like query syntax and then pushing the data to Power BI. And even with this, it took us like a couple of days to build these end-to-end pipelines. So you can see that how you can use Cortana Analytics and the services in Cortana Analytics to gain real-time as well as predictive insights into the data. And now I've shown you 3 separate verticals. I also want to show you a 4th one, and here I'm going to be playing a video. So this is Dartmouth Hitchcock, and they have used Cortana Analytics to do personalized healthcare. So Dartmouth Hitchcock is a big healthcare provider in US, and they have been using Cortana Analytics to gain real-time as well as predictive insights into the data. So let me go ahead and play this particular video.
The U.S. healthcare system is challenged by the task to deliver exceptional, personalized care at a lower cost. Despite spending nearly 1/5 of our gross domestic product on healthcare, we struggle to meet this goal. Financial pressures on care providers are increasing. This isn't sustainable. So how can we deliver high-quality, personalized care that patients deserve, given the cost pressures we face? At Dartmouth Hitchcock, we've created Imagine Care, a new cloud-based solution built on Cortana Analytics Suite and Microsoft Dynamics that enables providers to help patients achieve better health. With the help of Microsoft, Dartmouth Hitchcock is building a technology platform to serve healthcare organizations and patients across the country, setting a new standard for personalized care. Now, using machine intelligence, providers can develop a care plan that's unique to each patient. We can monitor patients from their homes, where data is collected from devices and sent to the cloud, to Imagine Care's 24/7 contact center, where registered nurses continually monitor a patient's health status and potentially serious trends.
Cortana, summarize health status for Ben Andrews.
Ben Andrews' weight has increased more than 2 pounds in the last 24 hours. Please review the home diuresis protocol prescribed by Dr. Phillips.
Patients get reminders and encouragement and dynamic updates to their care plans, improving their health, helping them avoid unnecessary trips to the emergency room, and reducing the cost of care. With support from loved ones and real-time interventions, there is less likelihood of readmission. With Cortana Analytics Suite and Microsoft Dynamics, we're transforming the way healthcare is delivered today, improving patient outcomes, reducing costs, and offering an unprecedented level of personalized care.
All right, so now I've shown you 4 separate use cases along 4 separate verticals, and you can see that the patterns are quite similar. They're using the same services to gain end-to-end insights into the data and do real-time as well as batch insights for the data. And only when the enterprise is able to do this, they can truly become an intelligent enterprise. So with that, I would like to end my session, and there are certain resources that you can look for on the Cortana Analytics that will explain you different use cases. They will talk about all the end-to-end solutions that we are building for different customers, so customer success stories. Now I would like to open up for questions if you have any. None? So I believe everyone understood everything. All right then, that's it from me. So please feel free to evaluate the session. And thank you.